In this video, I will explain you what is permanent magnet and temporary magnet. Now, how we are producing a magnet? We have a ferromagnetic substance. We are keeping it nearer to a magnetizing intensity of H. Now, this will produce a magnetization inside, right? Now, when we are plotting it on a graph, magnetization is basically a magnetic field inside, right? So when we are providing an H, it will produce a value of magnetic field. Let's say we have given the value till H and we got a magnetic field. This one is the magnetic field at this position. Now, though we are removing H, that will have certain retention of the magnetic field that has developed when we have given a magnetizing intensity of H. So this is the maximum value, but we have reduced the value of H to 0. Now we have a retention here, right? Let's say some substances have a retention which is very close to the fully magnetized condition. So this is the fully magnetized condition. That is the magnetic field that represents the fully magnetized condition. When you are removing H from this value to 0, what is happening? The magnetic field has just dropped by a small value and this magnetic field can be retained now. But certain other material, when we are providing H, that will produce magnetic field inside, but when we are removing, then the magnetic retention will be here. So this is a fully magnetized condition, but now this one retentivity, that is H dropped to 0 and the retention is this much. Now the curve may be like this, and this is one curve and this is another curve. See, here retention is more, here retention is very less. So this is best suitable material for making a permanent magnet. Though we are making H is equal to 0, that will develop or that will retain certain magnetic field inside. Substances like steel and chromium steel are best suitable for making permanent magnet. What property make it possible? Its retention make it possible. We have magnetized it, then we brought magnetizing intensity to 0, still magnetic field is retaining inside. But here in this case, this is fully magnetized, but the moment H is dropped to 0, this is kind of demagnetized, but still there are certain magnetic field inside, okay, but we can use it for a temporary magnet purpose. What is the application? We should be able to immediately magnetize an object, and at the same time we should also be able to demagnetize the object. So it is possible here, but it's not that possible here. For example, here we have a crane and crane is attached with a temporary magnet. Now the crane have to lift a car. So car is a metallic substance, right? So the crane temporary magnet will be brought very close to the car and this will be now magnetized. So this is temporary magnet. The moment it is magnetized, there will be a lift. The car is attached to it. Now from this position it is taken to a new position. Now the temporary magnet is here and car we have here. Now we have to drop it here. The moment we demagnetize, what will happen? The moment we switch H, the moment we turn off the circuit, H will become 0. What will happen? The retention is very less. That will be demagnetized. We can drop the car. So from one position to another position we can drop. If at all, if this is permanent magnet, what will happen? The car will be attached, but though we are keeping H is equal to 0 at this position, can we drop off the car? No, because it will have magnetic intensity, higher retention inside, almost the same as that of fully magnetized condition. So still the car will be there at this position. So for this application, we will use those material that has got lower retentivity. Okay, for this physics lab, we are using bar magnet and U-shaped magnet, right? For that we will be using substance like this, because though still we are not because for those substance, though we are not providing magnetizing intensity, that should be capable of using as magnets, right? So for that we need materials like this. Okay, thank you.